Schema evolution in Iceberg is one of those features that'll make you wonder how you ever lived without it. Now, imagine this scenario. Marketing needs you to rename a column. Let's just say they think it's really important. In the old world, it's like, let's schedule some downtime, coordinate across teams, do a big, load of the new table, update all the queries and all of that stuff, right? That's terrible. Or what if they want to drop a column? Suddenly you're dealing with position shifts, broken queries. Iceberg fixes all those things. Before we get to that though, maybe we want to look at what the data types even are in Iceberg. You've got the usual suspects: Boolean, int, long, float, double, decimal, the whole gang is there. You've got string and binary and some interesting things. There's timestamp, that's not that interesting. Timestamp Z stored with a time zone, and struct and list and maps, the complex data types for modeling more interesting things in your domain. But that's not all. Version 3 of Iceberg introduced 3 major data type additions. First, there was the variant type for semi-structured data. Say you've got a column that has JSON data and the thing that you're ingesting. Before version 3, you had 2 bad choices. Flatten it all out to a very wide, sparse table with lots of nulls in it, or store it as a string and then forsake any kind of query performance if you have to index on anything inside. You're gonna have to scan all those values and do a lot of filtering post hoc. Nobody wants that. Variant encodes that semi-structured nested data efficiently in a binary format. So you keep schema flexibility and give the engine the ability actually to push filters down into the query and process that data efficiently. So it really is a way of treating a JSON column kind of like JSON. It's good stuff. Second, there's the native geometry and geography types for geospatial analysis. If you're not working with location data, you don't care at all. If you are working with location data, sort of physical things in the world, you care a lot. You can now store and query those polygons and all the GIS stuff natively without awkward workarounds and converting the data structures into unfortunate things that a bunch of work on your part. So native geospatial support, really good stuff. Third, nanosecond precision timestamps for high frequency event data. Now, if you are setting the event time of events you're ingesting based on, as we say in the streaming world, the wall clock, whatever the clock is on the server that's doing the ingest, you don't need nanosecond precision. This is where you've got some kind of telemetry or just a workload where there is an event being generated, usually by a device out in the world, that has very precise timing in it. Maybe it's got a GPS receiver in it and it's got access to a high precision timestamp, and that's in the message itself. You want to represent that in the database as a nanosecond accurate timestamp. Now you have that. So these really aren't just nice to haves, they are unlockers of particular kinds of use cases that would have been so hard as to maybe not be worth doing in Iceberg. They really expand the kinds of things that you can do in your data lake when you're using Iceberg as a table format. So Iceberg's got your basic data types covered. But what happens when you want to change one of them, when your schema changes? And this is a thing. The world out there changes. The business has to change to adapt to the changing context out there in the world. That means columns get renamed. New fields appear. Old ones go away. Data types change. This is a thing. It's never pleasant. Anytime I talk about schema change, I always have to remind you that there isn't any system that's going to make this fun, right? It's always kind of a bummer when it happens. But support for this in the database is game-changing. It turns it from, this is a major project that could take 2 weeks, to, well, this is a mildly inconvenient thing that we had to do and it was no big deal. So huge thing that Iceberg supports. So the supported types of schema evolution in Iceberg are add columns, drop columns, rename, widen types, I'll get to that, reorder columns for readability, and this also works for complex types. We can change those as well. And those changes are all instant. Those are just metadata changes. There's no data files rewritten. That's just a snapshot, and an efficient one at that. And because Iceberg tracks every column by a unique ID, not a position or a name, that makes schema changes safe. If you drop a column, it doesn't shift things around. If you rename a column, all the old data files will still read correctly because they're all referring to the column ID, and you're just making truly a metadata change, just the name that we see that corresponds to that ID. This is in contrast to other formats where that position matters, which just sets you up for a lot of pain down the road. This is a really good thing. Best of all those old data files all remain readable with the new schema. That's the magic of that column ID. So backward compatibility is built in, your schema evolves, and nothing at the database level breaks. Of course, things at the application level, those can still break. Database is safe though. And this gets us away from things like accidental data resurrection, where you make a schema change and things come back to life, and that was a problem with previous versions of different types of data lakes. Data loss as your table evolves. Those are all things we don't want. So let's see how this works in practice. We have a basic table called user events. There are 3 columns: event ID, user ID, event type. All right, and we'll add some records to it here in this little pro forma way, just insert some values. A few weeks later, marketing wants to track the user's device type and the browser version to get more insights about user interactions. Okay, we add those columns, and we still have records coming in, right? So there's been records, now there are new records coming in with the new columns. If we query the table, we'll see we have a mix of records that don't have any values and some with browser and device type for those new columns we added. Good, classic relational database style kind of behavior so far. After a while, marketing says, you know what, browser version was not really very useful. We just let's not have that. So let's drop that column, and we do that, alter the table, query, boom, it's gone. Now you query the table again, you just don't see the dropped column at all. Okay, easy enough. That data is still in storage though. We can time travel back to where that column existed, to that period of time during which that column existed, and any snapshots created in there still show the column. Now, I'll give you a little bit more on time travel in a subsequent module, but in this quick example, this shows you the table as it was 5 minutes ago. We'll say that's just before we dropped the column. And so if you need to bring that column back, you can. You can roll back, and it's easy to restore it with the original data that is still there. So you drop the column, but due to the snapshotting feature and the immutable data and all that stuff, it's still there, that column. You can still go back to it. In previous versions of table formats, that drop data was gone for good, and now we don't have to put up with that anymore. Now, someone realizes event type isn't quite descriptive enough, and they want to rename it to action category. And we're like, okay, Mr. Data Scientist, we would be happy to do that. We're just going to rename the column. That's all we really need. There's no data file that's touched. It's a metadata change, and it really is just a metadata change in Iceberg. We just changed that name, and we don't lose access to historical data. Queries still work. It really is not such a bad thing. And just like before, in the history, if we look back in time, the old name is preserved. If we travel back to before the rename, it's still called event type back then. It's not called action category like it is now. Add columns, drop columns, rename, whatever, we keep the history intact. Now, here's what Iceberg doesn't do. It doesn't coordinate your rollout. So once you rename a column, every query against that table needs to use the new name right away. So if they're going for the most recent snapshot, which is the default, if you don't ask for anything different, of course, there's no grace period. It's not as if both names are going to work. So you still do need to coordinate the rename with applications, dashboards, ETL pipelines. This is why I say nothing can make schema evolution like fun. You know, this is kind of a hassle to do all this. It is, however, a part of life. And at the database level, as you see, Iceberg makes this about as great as it could be and gives you version history. You handle the rollout, you handle the communication and the cross-functional, timing with all the different teams who might care about the table. But the database is really not going to be a big part of the work there. And that's what we would like that piece of infrastructure to do for us. Widening column types. So let's say we've got user ID started as an integer, and now you've got more than 4.2 billion users. Well done. Okay, maybe you should have thought ahead, but you didn't, and we have to promote that to big int, and then you just do that on one alter table statement. The old data stays as 32-bit integers on disk. It's not rewritten. When you read it, Iceberg promotes it automatically to the wider data type. For any safe widening, that's int to big int, float to double, and increases in decimal precision, that can just be done computationally in a guaranteed way, this works. So let's say schema changes are piling up and your describe table and your select star get messy, you just don't like it, you want to reorder columns, no problem at all. You can move a column to the first position or position it after another column with the after keyword. It's just a metadata change. So again, no data files are harmed or touched in the altering of this schema. Action category, as you see here, now comes right after event ID. Iceberg also lets you evolve complex data types like structs and arrays and maps. So say you have a struct for user preferences. It's got an email notification flag and a color theme. Later on, you add mobile notifications and language preference. So in my engine here, this syntax, I use add column with the dot syntax to add fields to the struct. There could be engine-specific syntax differences here, so check your docs for the engine that you're using. But natively at the API level, Iceberg supports this. And existing data gets null values for the new fields, so everything keeps working. So existing data that had been inserted prior to this schema evolution here is going to get null values for those new fields, so everything keeps trucking along. Again, the application is going to need to be happy with those null values. Somebody's going to have to manage that, but the database makes it easy. That is schema and schema evolution in Iceberg. Instant, safe, thanks mostly to those field IDs and metadata. That's kind of at the core of a lot of it. But this flexibility requires discipline. Schema changes are so easy to make, effortless kind of in the database, that makes the rest of the system easy to mess up. So you have to test changes before rolling them out. You have to coordinate. You have to do all of the usual work with all the pipelines, all the dashboards, all the applications. All those concerns need to be addressed. Just because it's super easy in the database doesn't mean that you can be cavalier about the rest of that work. But Iceberg handles the technical complexity at the data plane level. You handle the governance. Do it right, and schema evolution becomes one of your most powerful tools.